Trim is set 12.1, 0, and 0 in the green boxes. Transfer knob. Forward, commanded. Bottom, commanded. Aft, commanded. And mid, commanded. Back to auto. And forward, commanded. Best profile, high 90-2 selected, start 30 and 65, duration 90.
Test control profiles confirmed. Your go as start stop button.
Brake pads is armed, braking gauge, status is clear, and here comes that start stop button. Good motion. And pads stopped. Pins are coming out. Our pins are removed and stowed. Cast inventory is clear, and you're going to disconnect Bluetooth headset. Chase test radio check.
Loud clear. 3005, I'm ready to go.
Copy. Be ready as soon as this panel's on. Bluetooth panels removed and stowed. Ready. We're holding at step 69 shocks.
Test control. Your go step 69. Permit trucks.
Alright, ready. Nope, I'm not up ground. Stand by one.
Let's change your test taxi.
Okay, copy. I'm up with you on ground now.
Test control. Your go taxi. Copy 0111.
Let's change it to 010.
Let's mark in 0111. profiles look good. Trim showing 11.6.1 right, 0.2 left in the green box. Ready for takeoff. Anti-skids. Auto. Backup high pump. Auto. Transfer knob. Auto. FLVS selected. GoPro's on and recording. Parachute and seatbelt connected. Pins are removed and stowed before takeoff checks complete. Boom, standby check-in. Test.
Chase.
That'll do.
Control.
Test towels, your winds are within limits. We're showing consistently about 060 at 5 knots.
Test copies. Alright, looks like we've got 200 pounds, about 200 pounds to burn, so maybe call for takeoff in 2 minutes. What do you guys think?
Test control, that works for us. If you want to take the runway at 10:46, we expect about 30 seconds of burn, and then you'll be within band.
Okay, let's make it 10:45, and then we'll be ready to go right on time, I think.
Control copies.
Well, good afternoon, and thanks for joining us live from fabulous Mojave, California. My name is Nick Schreika. I'm Boom Supersonic's Chief Flight Test Engineer, and thanks for joining us on today, our live stream broadcast of XB-1's second supersonic flight. Just to catch you up real quick, in case this is your first time joining us for one of these, XB-1 is our approximate one-third scale technology demonstrator for our commercial airliner project, Overture, still in development. This is XB-1's 13th flight and the second time that we're targeting breaking the sound barrier. Joining me today as co-host, I'm honored to introduce Blake Scholl, our CEO and founder of Boom Supersonic.
Yeah, good morning, and thank you. Good morning, good afternoon. Thank you, all of you around the world, for joining us today. It is an exciting day here in the Mojave Desert. It's always an exciting day in flight test, but today is an especially exciting day. Earlier this morning, we made an announcement that some of you may have seen about Boomless Cruise. On XB-1's first supersonic flight just under 2 weeks ago, we broke the sound barrier not once, not twice, but actually 3 times, each time without making an audible sonic boom. And that is a really big deal because that technology scales up for Overture. It's going to allow us to enable supersonic flights over land without any audible sonic boom. We'll talk more about that later today. But as we speak, it looks like Geppetto is taking the runway here.
Yeah, Blake, so thanks for mentioning that. We actually have 3 objectives on today's test flight specifically for XB-1. The first one is to collect more data on what you mentioned there, that boomless supersonic cruise technology. And then also, we're going to try to capture a really special kind of image. It's called a Schlieren image, and it allows us to see the shock waves that XB-1 produces as it flies supersonic. The third objective, of course, is to just safely demonstrate repeatability of supersonics with XB-1. And what you're hearing right now is Geppetto's doing the final checks of all 3 engines, just running them up one last time to make sure everything is within parameters and everything's in the green.
Stable.
I expect the takeoff to happen momentarily here.
Yeah, we expect to be off the ground at 48 past the hour. We'll talk about this more as the flight unfolds, but today's flight is one of the most technical ones we've done in the program. It involves some very precise flying in order to set up for what should be just a beautiful image of XB-1 breaking the sound barrier.
That's right. I'm really excited about this one. You can see in some of the shots there, we're joined by one chase aircraft today, T-38, and that's flown by Wiper, is his call sign, Matteo Brambilla, with Ruslan Pashenko in the back as Photog. Hopefully it'll get some really great air-to-air shots again.
Yeah, and once again in XB-1, we have Tristan Brandenburg, call sign Geppetto, our chief test pilot rather, and this will be Geppetto's 12th time flying XB-1. He's been our chief test pilot since the second flight, and he was in the seat 13 days ago when XB-1 broke the sound barrier for the first time. And it just takes incredible pilots, not only the courage to go take an airplane, a brand new airplane, and to do with it something that it's never done before, but also on today's flight, it's going to be a real demonstration of flying skills, as we have to hit a very specific point in the sky at a very specific time in order to capture that image.
About 15 seconds.
All right, so you heard the call there, about 15 seconds from pushing the throttles up. Let's just watch XB-1's takeoff today.
All right, I'll put myself in band.
Test control, you are in band and go for brake release.
Copy, go for brake release.
See the 238 there, it'll follow in what's called an interval takeoff. We expect about a 10-second delay. The T-38 will follow XB-1 off the runway, and then they'll rejoin in the air. Here we go.
Boy, it just never gets old to watch this. I feel
Absolutely.
like there's nothing quite so human as flying. Just gathering speed, going down the runway.
You see rotation about 165, and we're airborne about 195 or so was the speed I saw.
Oh, what a beautiful sound. A beautiful view.
That never gets old.
It never, ever gets old. Just an absolutely beautiful airplane. Physics does not let you make an ugly supersonic jet, not by any stretch, and XB-1 is just a beautiful machine. So, Nick, what's going on now?
Okay, so we just saw XB-1 leave the ground, and XB-1 turned right. It's heading out to the east, and we're going to fly up east and enter the airspace above Edwards Air Force Base. And then we're going to fly out about 60 miles or so to the east. We'll turn west and enter again the same piece of airspace we were in on our last flight. We call it the Bell X-1 Supersonic Corridor. It's named after, of course, Chuck Yeager and his famous flight conducted in 1947, which was the first ever supersonic flight of any manned aircraft. So we're using that airspace because that is the appropriate place to do supersonic testing. And we have a special agreement with the Federal Aviation that gives us the authority to do that with our test mission here today.
Yeah, we're super proud and grateful. The FAA gave us actually the first ever authorization to break the sound barrier in a civil aircraft over land in the United States. Also grateful to the team at SpaceX and Starlink who are providing a pretty impressive antenna that we have in the Chase T-38 airplane. That's what allows us to get these live air-to-air views.
Yeah, this one actually I think is just a zoomed-in camera from the ground, but hopefully that Starlink comes up here pretty soon, and then we'll be real close. But, you know, we talked about this on our last flight. XB-1 just out-climbs the T-38. It's a very performant aircraft, and sometimes it's hard for the T-38 to catch up. So as soon as they get a little bit closer there, we'll get some of those more dramatic shots closer in.
Yeah, no, I remember the first time I flew the XB-1 simulator on the ground, and I was climbing at about 14,000 feet per minute. I turned to the team and said, well, this can't be right? It doesn't really perform like that, but yet it actually does.
No, it does with all three engines pushed up. And again, we talked about this last time too, but we have to design for the off nominals. And so if you lose an engine on takeoff and your gear are still down, you have to be able to climb very well with only two engines in operation. So because you're designing for that condition, when everything's working nominally, you just have a tremendous amount of performance on tap.
Yeah, just absolutely incredible airplane. Well, let's talk a little bit more about today's mission. Nick, will you tell us how the Schlieren photography works?
Yeah, so we're going to fly a flight path today where XB-1 is going to be flying in a very precise position in the sky. And the reason why we're doing that is because we have a team on the ground. They're actually NASA employees, and they have a ground station set up remote in the middle of the desert. And we chose that position because of the location and where the sun will be. We're going to use the sun and use the collimated light that comes off of the sun. There's an image there on the screen. You can kind of see a description of what I'm talking about there. And NASA has special optical equipment and special cameras that they can use to capture that image. What we need to do is eclipse the sun. And by eclipse the sun, I mean we need to fly in front of the sun relative to the position of the equipment on the ground. And that's a very difficult, challenging thing to do. The sun's apparent diameter is about 500 feet or so relative to the size of XB-1. And so we have to get precisely in the center of the sun. Gives us about a 250-foot tolerance on either side. And we need to get the timing perfectly, too, because the XB-1 is going to cast a very small shadow on the ground, and it has to fall exactly on where that team is on the ground. And unfortunately, we asked, but the sun just keeps changing positions. It won't stay in the same spot. So every moment that we were flying this mission, we have to kind of recalculate the precise timing and location where we need to be. So it's challenging to do the math to predict how all this is going to work with a dynamic airplane, a team on the ground, and the sun changing position. We need good weather. We obviously can't have we can't have clouds or anything like that. And Geppetto is going to hand fly this and needs to do so very precisely to hit that tolerance. He needs to issue a command. He'll say 5, 4, 3, 2, 1, mark. And when he says mark, the team on the ground will engage highest frame rate cameras to collect that data that they'll then post-process and produce, which referred to as a Schlieren image. Can we bring the graphic up of what one of these things look like? So here's an example of a T-38 that was flown in the past, and you can see there, you're basically seeing the invisible. This is something that you can't see with your eye, but with a special technique, you can visualize the actual shock waves that come off of the airplane. And not only just beautiful, we can use this to validate and correlate the tooling that we use, their CFD predictions of how the aircraft will perform. Supersonic, it validates all of that. So that's why we're really excited about getting this data today.
Yeah, and that really goes back to the very reason that we built XB-1. This is the first ever independently developed supersonic jet, and it is the first time this team has come together and built a supersonic jet. And so we did XB-1 to learn 100% of the lessons of what it takes to create a human, safe, supersonic jet, and also to collect all the data, all the calibration for the engineering models that will allow us to make that Overture airliner a success.
Mm-hmm. Couldn't agree more.
So what's going on right now? What's Geppetto doing?
So here, this looks like a Starlink live feed right now. So this is coming live from the backseat of the T-38, and you can see XB-1 there. He's flying an area chase, and he'll get closer as needed throughout the mission. We talked about this earlier. XB-1 just frankly outperforms the T-38 in most scenarios. So when we do the supersonic dashes, I do expect the XB-1 to outrun the T-38 a little bit, and so we'll get as much imagery here as we can. Talking real quick about the data that's on the bottom of the screen. First, on the left there, you have flight time, and that's just 6 minutes since our wheels left the ground. Altitude, we're still climbing. We're at 25,000 feet, continuing to go up. We're at Mach 0.8, so about 80% the speed of sound. And the airspeed there is a true airspeed. So there's a lot of different airspeeds that you talk about when you're flying an airplane. There's indicated airspeed and NOTS equivalent airspeed, but this is true airspeed, so the actual speed that we're traversing through the atmosphere. And then on the right, we have a graphic there about our engine status. You can see all three engines are engaged in afterburner right now, and that's to finish the climb. We get better climb performance up at these upper altitudes with the afterburners engaged, really any altitude, but it's actually more fuel efficient to climb with afterburners when we get really high. It burns more gas, but it actually takes less time, and those two things trade out very well at the upper atmosphere. Mm-hmm. On the left, you can see an image of just a moving map image of approximately where we are. We're still headed out to the east, and so we'll start to talk about that supersonic run once he turns right and heads back westbound. So we talked about like why we're flying in the piece of sky that we are today, but we're also collecting some data additionally as kind of a ride-along test point, and that relates directly to that boomless supersonic flight that we were talking about. Blake, can you explain a little bit more there?
Yeah, I mean, so for a long time, one of the impediments of supersonic flight has been, right there in the name of the company, it's the boom. And, what we demonstrated not once, not twice, but 3 times on XB-1's first supersonic flight is the ability to break the sound barrier without an audible sonic boom reaching the ground. And that's not magic. It's not even part of the airplane design, really. It's about how you fly the airplane, the altitude and the speed relative to the current atmospheric conditions. Many kids think back to like high school physics. You've probably seen that experiment where you get a glass of water, you drop a pencil in it, and then it looks like the pencil's broken. Well, that's because light waves bend as they go through different media that have different local speeds of light. And it turns out this is really true of any wave, and it's true of sound waves as well. So when the boom comes off the airplane, it passes through the atmosphere, and the atmosphere is not the same temperature. It's actually colder above and warmer below, and that means that the speed of sound, which is a function of temperature, also varies. So just like light waves bend, so do sound waves, and they bend towards colder temperatures. So they make kind of a U shape as they come off the airplane. Now, if you break the sound barrier at too low of an altitude or too high a speed, those rays will then hit the ground, and that's when you hear a sonic boom. But if you do it high enough at the right speed, it actually creates a U shape in the atmosphere. The boom turns around and it goes back up before anybody could ever hear it. And that is a big deal because that's what's going to allow us to legalize supersonic flight over land in the U.S. and in the rest of the world, and then speed up not just transoceanic flights, but flights across the country as well.
I think we had a graphic that could help articulate that point. Is it possible to bring that one up on the screen? Yeah, so there you go. This is just roughly explaining what's going on here, and we refer to it as a cutoff altitude. Below that, you just do not hear the sonic boom.
That's right. Yeah, and so today, so exactly how these waves propagate is a function of the current atmosphere. What are the winds? What are the exact temperature gradients? And our forecast today is that we're going to have a cutoff altitude about 7,000 feet.
Yeah, I believe that's correct, about 7,000 feet. Below that, you won't hear it. So it looks like Geppetto is now lining up for the first supersonic dash. I'd expect him to start accelerating here pretty soon. So let's listen in and watch XB-1 on its 4th supersonic dash. On condition right there. You see the center.
Switch to manual power. We think we'll be ready by the time you spin it. If you can give me a time estimate, I'll get you new data.
Time 11:15.
Okay, so I think what happened there is our timing was a little bit off.
11:15. Yes.
Copy 11:15.
And Geppetto is, they said spin it. So what Geppetto's going to do right here is make a 360 and come around for another attempt. Now we have pre-calculated exact position timing for the even numbered minutes on the 10s. So 11 a.m. was our planned first supersonic target. Followed by 11:10, 11:20, 11:30, etc. As many as we have fuel for, frankly. We're going to do this pass as many times as we have fuel for. We believe we'll have enough fuel to do at least 2 or 3 attempts. But if we're not precisely on that time, we've pre-thought about this, and we have charts where we can manually recalculate a new altitude to do it at, and recalculate a new timing and a new spacing. So we can do this at any time. We have just kind of pre-planned the even number of minutes, but we can recalculate a new attempt dynamically on the fly. And this is something we've actually practiced. We have flown this rehearsal twice in the T-38. The first time we did that, it was a full dress rehearsal, and NASA was on the ground, and we were actually able to achieve 2 out of 3. Geppetto flew it the first time, and he missed it. He was a little bit high. He took that feedback, adjusted the technique a little bit, and again, this is all hand flown by Geppetto. And so he was able to hit the second one, and then again repeatedly on the third one. He practiced this flight again on Friday, just to shake the rust off a little bit. And if I know Geppetto, he's looking to sink every shot that he takes. So he likes a challenge, and now he's got to go off the card, so to speak. So we're not flying the precise GPS location that is written on the cards, but we're calculating a new one, and he's gonna go for that dynamically.
Yeah, again, it just really speaks to the skill of the pilots, but it also speaks to the skill of the team that designs and supports the flight. Nick, we implemented some features in the avionics to support this just in the last 2 weeks. Can you tell us a little bit more about that?
Yeah, that's right. So we basically use this the same code block that we use for our ILS landing needles, the same kind of things that airline pilots use to land an airplane at any airport in the world under ILS conditions. And we repurpose those needles, those guidance needles, to give Geppetto the information that he needs to fly precisely on time, on target. And this is something that one of our software engineers on the team, Jason Reichenecker, he just went to town with it, collected all the data from NASA, and wrote a custom application similar to that ILS needle system that basically gives Geppetto the cueing that he needs to fly so precisely. All of these points are flown off a GPS altitude and not a pressure altitude. That's because the sun's position in the sky doesn't really matter what the atmospherics are doing on any given day. So he's looking at GPS altitude and then the guidance provided by that custom boom written code that's on the primary flight display right in front of him.
Yeah, and again, it speaks to the power of having control over that whole airplane ourselves. Most of the airplane was designed in-house by Boom, built either directly ourselves or with our own people directly supervising the suppliers that are building those components. And this has led to some of the many lessons learned out of the XB-1 program about the importance of, okay, so here we go. We are, it looks like the afterburners are lit. And we are accelerating, and so all right, it's time to get excited.
Here we go, and 0.9, this is where it paused last time. That's expected because of the error in the air data system. Once we get deep into the supersonic regime, yeah, there we go.
There we go.
All right.
And XB-1 is supersonic now for the 4th time.
Mach 0.16.
Now, what speed are we expecting Geppetto to accelerate to today, Nick?
Okay, so we're targeting a true Mach number of 1.14 on this dash. Now, we learned on our first supersonic mission that the air data system does have a little bit of error in it. Any pressure transducer, any piece of instrumentation will have a little bit of error in it. And so we're compensating for that. And we're going to fly a little bit faster because of that error. So you might see an indicated Mach number of 1.14 to 1.19 or so. And we're dynamically adjusting that so that we're at 1.14 true.
Beautiful. And then that is a new top speed for XB-1 right there, right now, and on today's flight.
Just heard a 30 seconds call.
Slow down, recover.
Maybe got a little fast there, but we're still supersonic.
10 seconds.
10 seconds.
10 seconds.
5, 4, 3, 2, 1.
Mark. Okay, so there you have it. That was the first Schlieren pass.
Recover, we do not have TM.
Okay, lost some TM.
Chase, I need you to recover. They drop out.
Throttles are out of burner. I'm recovering.
Copy that.
All right.
Chase is recovering.
So let's explain what just happened there. You see the data had froze on the bottom of the screen. We've just lost our telemetry link with XB-1. So I'm sure the avionics team is diving into that right now and just looking for a fix. But we did get one Schlieren pass on that. Geppetto will probably circle. And we've also spaced these Schlieren shots 10 minutes apart to deal with contingencies. And also the team on the ground, their camera systems, they record a very high frame rate and they make these massive data files. It takes them about 5 or 6 minutes just to offload them and reset the equipment for the next pass. So we're planning on doing Schlieren attempts on center 10 minutes apart from one another. The numbers are changing now, so it looks like they've fixed whatever telemetry bug crept in there on that run.
Yeah. Now, this is something that we've been working through on the entire flight test program, making sure we've got reliable radio communications, reliable telemetry coming off the airplane. In some ways, you can think of XB-1 as it's almost like a flying data center. There are roughly 10,000 wire terminations on the airplane and many megabits of data coming off in real time. And that comes off the radio and antenna, digital antenna on the bottom of the airplane. We've got dishes that track it, line of sight. And then that feeds the control room, and a couple dozen flight test engineers are watching their stations and able to watch everything on the airplane. Now, speaking of that, on the first supersonic flight, for those of you who tuned in, You might have heard a knock it off call. And Nick, can you tell us what's that all about? Is that people just having fun, or?
Yeah, it's kind of a funny term, knock it off. It's like, what is somebody like just goofing around in the control room or something like that? It's actually an industry standard term. And what knock it off means is it's just something that's very clear when you hear it over the radio. There might be some static or something kind of interfering with the communications. But knock it off just means stop the test point, because we're seeing something that we didn't really necessarily expect. And so specifically in that case where we heard a knock it off call on our last supersonic run, we had been operating in Afterburner for longer than we had ever been operating with Afterburner before. And the rate that temperature was increasing was doing so at a higher rate than we had ever seen. And so an engineer saw that and diligently called knock it off. We slowed down. We checked the values, and we realized that everything stayed within limits. There was no exceedance or anything like that. It was a precautionary measure, so we don't expect that to be a problem. But you might hear knock it off if any engineer sees any of the thousands of parameters that are being beamed down look unique or new or something like we haven't seen before.
Yeah, and that's actually, it goes to very much to one of the things we've built here on XB-1. It's not just the airplane itself, but it's a safety culture, and that's a culture in which everybody is encouraged, and not just encouraged, but actually expected to speak up. The team starts their day every day with a daily stand-up, and the first agenda item of the daily stand-up is, were there any safety or quality issues from the day before? So in a certain sense, every member of the team has access to the e-stop button, and if they see anything that they don't feel as meeting criteria for safe flight, they're absolutely encouraged to speak up, raise their hands, and say, hey, let's deal with this, and then move on.
Yeah, we do it every single morning as part of our daily brief, and then we also do it in the control room when we're flying missions live. We call it the no vote. Everybody has a no vote when they see something that we need to slow down and take a look at.
Yeah, it's absolutely fundamental to building a safe airplane. And we know we're in the business here at Boom of taking what we've done on XB-1, scaling it up to create an airliner that any of us can fly on. And so nailing not just the technology, but the safety culture and that reliability is super important. So it looks like as we speak now, Geppetto is kind of coming around, getting set up for another Schlieren pass. And while we're doing that, why don't we talk a little bit more about that boomless cruise and what it really means for our future Overture passengers. When we started the company, we were very focused on enabling supersonic flights on the transoceanic routes, the ones that are today the longest flights, the New Yorks to Londons, the LAs to Sydneys, that tend to be mostly over water. And you put the boom out over open ocean, where there is just nobody there to hear it. Therefore, it can't be objectionable. But we always knew we would want to bring supersonic flight to all passengers on all routes and provide even more opportunities for speed ups. And so as we've gone through development on the Overture airliner, what we found is there's an opportunity, as we demonstrated in XB-1's first supersonic flight, to bring boomless cruise for overland flights. And that's enabled by a few things. Like we talked about earlier, the airplane has to break the sound barrier at the right altitude, at the right speed for the conditions of the day. And that means we have to have enough engine thrust. And so this is where the ability to develop our own engines is a really big deal. The Symphony engines have much better transonic performance than other commercially derived engines, which means we can punch through the sound barrier at a higher altitude and keep that sonic boom from reaching the ground.
Well, that's just because they're a point design for supersonics, and they're not a derivative of a subsonic engine.
That's right, yeah. I mean, so the team building Overture basically has an in-house engine company that can build us exactly the engine that the airplane wants to have, and that is a huge deal for the airplane, a huge deal for us to be able to optimize every bit of that performance. Additionally, computing power is a big deal here. Is because the speeds and altitudes required for boomless cruise vary from day to day. Being able to have real-time weather data and real-time sonic boom forecasts are enabling us to go reliably fly supersonic while being confident that there's never going to be an audible sonic boom on the ground.
So what you're saying there is that we have this graphic that kind of explained the concept, but that's something that we're going to embed in Overture, and that'll be a real-time calculation that can be done at any time. And you've even discussed, you talked about like maybe an autopilot feature where we could leverage that.
Yeah, I think the autopilot in Overture will have sort of a boomless mode, and when that's engaged, the autopilot will automatically fly the right speed to ensure that no boom is heard on the ground. And if it turns out there's a more optimal altitude that will allow even faster speeds, it'll cue the pilot to request a different altitude of air traffic control.
And so looking for confirmation of that boomless flight, we've talked about why we're flying exactly where we are, and that's to enable this Schlieren imagery that is the focus of our test plan. But in addition to that, we have two data collection centers basically on the ground right now. One of them is approximately 10 miles in front of XB-1 supersonic path. The other is about 20 miles in front of XB-1 supersonic path. And they're basically some sophisticated microphones. And we're sitting there waiting for confirmation that no boom was received, basically. If we record absolutely nothing, that'll be a win there. But we strategically placed those on the ground looking for confirmation of the Mach cutoff, and that it was a boomless supersonic cruise. We got word actually from one of those two teams that on our first supersonic pass, there was in fact no boom heard on the ground.
There we go. Well, that makes 4 times we've broken the sound barrier with no audible boom. And all of that data, again, just goes back, fed into the algorithms and machines that will allow us to just do this reliably day in and day out. You know, supersonic flight today on XB-1, it's incredibly exciting, but, you know, we're not done until we've made supersonic flight boring and routine.
That's right.
So it looks like we're getting ready for our second supersonic pass here, getting set up again for another take at getting that Schlieren image.
Yeah, it's interesting. You know, one unique dynamic of flying around in this airspace where there's so much military testing that happens on. It's a very busy radio frequency environment. You got lots of different teams doing different things with telemetry. There's GPS denied environments that are that we have to kind of navigate around to do our testing. So we're very thankful for using this airspace, but it's challenging to do so and maintain our comms, maintain our telemetry, maintain good GPS signal integrity, etc. But I do see Geppetto. He is pointed back west again, and he is inbound for the initial fix on what looks to be the next supersonic Schlieren pass. So maybe about a minute or two out from that at this time.
Yep. So when we're getting ready to go supersonic, what we'll see. There we go. All 3 afterburners are now on, and we should expect to see the Mach meter start ticking up here.
Awesome. Okay, here we go. Speed is increasing.
Yeah, you know, so a supersonic flight is exciting. You know, one question people ask me a lot is what is it like on board the airplane when the airplane breaks the speed of sound? Nick, what is it like?
I hear it's transparent. There's really no sensation to the people in the airplane when it goes supersonic, like this moment right here that Geppetto is just about to experience.
Yeah, they should click over any moment now.
There we go.
There we go. Once again, XB-1 is supersonic.
5th time.
5th time. Seems like it works.
Awesome.
Yeah.
So, you know, Concorde famously had a big readout in the cabin because nobody could tell, but it was pretty cool to know that you're going supersonic. But
yeah.
You can't tell from being inside the airplane.
Yeah, you know, we will do that on Overture too. We'll make sure you have a big display on the speed and that moment of breaking the sound barrier is celebrated. But it really is, you have to go make a big deal out of it because otherwise nobody would notice. It's completely transparent.
Mm-hmm. Okay, so Geppetto has decelerated again. I see the engines are at about 80% or now. And after that dash, we're turning to the right. It looks like Geppetto might be circling to regroup for position. I was also quite sure we might have lost telemetry on that one again. So unfortunate, but these are the things that come up when you're flight testing an aircraft, is sometimes telemetry doesn't play very well. Yep, he's circling back to the right. We'll see if he sets up for a 3rd pass here. So, like, why does supersonic matter to the? This is a test airplane on a test mission, but why do supersonics matter to everybody watching here today? When will this be applicable to them?
Yeah, well, I mean, supersonic flight is not about going fast because it's really cool, although it definitely is really cool.
Yeah.
It's about enabling us to do things in person that otherwise we wouldn't do, for us to go places, meet people, have experiences that otherwise we couldn't happen. And to get, I think that the best real sense of that and how it changes the world is to think back to what happened last time we had a real mainstream speed-up flight, which is when we went from the propeller age to the jet age in the late 1950s and early 1960s. And as flights doubled in speed, we didn't actually spend less time flying. We spent more time flying, as it was possible to just access so much more of the world so much more easily. Like Hawaii was basically not a tourist destination before the speed of the jet, and the jet is what it made what enabled us to have an island vacation. And so if we think forward to a supersonic age, what happens when Sydney, Australia is as easy to get to as Honolulu is today? Or what happens when flights across the country with boomless those crews could be 90 minutes faster than they are now. That means something like you could leave New York at 9 a.m. New York time, and you could land in San Francisco around 10 a.m. San Francisco time, and get your whole day started. So it's just that power of time savings gives us back that irreplaceable thing. We just can't get more time back. Speed is what gives us that, and it also just unlocks new possibilities.
Blake, I've done some of those flights. I've been to
indicated Mach number 36025 altitude.
Okay, so you just heard a real-time correction there. We're calculating for a new time for our next Schlieren pass. That's what that comm from Erin, who's leading the control room team in the control room today. Erin Young. She's actually, I think she's been at the company longer than anyone except for you, Blake. She joined the company way back in 2016, and she's been around longer than I have. So it must be hugely important to her to lead this mission after having been there since XB-1 is basically a blank sheet of paper in front of her on a desk.
Yeah, I mean, I remember when Aaron interviewed at Boom, the company was still in my basement in Denver.
That was HQ1, right?
That was HQ1. It's sort of, sort of blows my mind that people of this caliber are willing to come interview in a company in somebody's basement, and were actually willing to sign their job offers, join this team on the promise that one day they'd be able to go flight test a supersonic jet. And I remember that conversation with Erin, talking with her about the kinds of things she might be able to do one day, and here we are. She's leading the control room on the XB-1's historic supersonic flights.
Mm. And joining her today, Jeff Mabry, our VP of the program as test director. And his background, he came out of the Air Force and then worked for another startup before joining Boom. But he's been here a good while too. Jeff joined in 2019, and then you can kind of see Aaron standing up right now in that image, and right in between him, Warren Koenig. He is our chief engineer on the program, and he's actually helping the back row on this mission and facilitating the communications between the team on the ground at NASA on the ground and the control room there.
Yeah, no, the team is really the most important thing here. First off, you would not be able to do this without just an incredibly talented team. XB-1 was done by about 50 people, including the designers, the engineers, the technicians that assembled the airplane, the pilots that flew it, the management. So I think that's the smallest team that has ever built a supersonic jet. For sure. Yeah, and it has given us the only team on the planet, the only team that has designed, built, and flight tested a civil supersonic jet. Of course, there's some teams that have done this in the military world, but that's very different, where you're not constrained by budget.
And just recency. I mean, the last supersonic flight of any new clean sheet airplane in America was the F-35, and that was in 2006.
2006, yeah, it's been a while.
Yeah, so this really, I mean, the first supersonic of any kind in about 2 decades, but the first, more importantly, the first one that has been completely independently funded, developed, built, and tested.
That's right. Yeah, from starting the company took us almost 11 years to get to today, and yet knowing what we know today, I think we could have done it in half the time, probably with about a quarter of the money. But that's why we did XB-1. We wanted to learn those lessons and enable us to then go off and execute the Overture airliner.
That's what you call paying the tuition, right? This was a hard airplane to do, but we learned so much in doing it. We could have designed a drone, and that probably would have been a lot cheaper and a lot faster, but we just wouldn't have learned as much.
Yeah, in XB-1, in many ways, we made the job hard. We made it hard to do it human piloted, not as a drone. That means failure is not an option. You have to bring the airplane and the pilot home. We did not put an ejection seat in the airplane, again, for that same reason. We did not want to give ourselves a get out of jail free. We wanted to build the safety technology and the safety culture that would make Overture possible. All right, well, it looks like that Mach number is creeping back up again.
Accelerating 3 afterburners. Here we go. There we go. The 6th time XB-1 is supersonic again. And on this mission, we're a little bit higher, but just because of the later time in the day, we're compensating for the sun changing position. A little bit higher, and we're going a little bit faster. We're going to target 1.15.
Get it back in 30 seconds, I can accelerate again.
We're fighting through some telemetry issues, and so that's what you're hearing there in the comms, is the data has frozen. That just means that the radio link between the ground and the air is unfortunately just not behaving very well today.
Yeah, and so when we don't have the telemetry data, we tend to back off on test conditions a little bit, again, because the entire point there is that we've got a couple dozen engineers able to watch their displays in real time, monitor thousands of parameters, and make sure that everything on the airplane is performing exactly as we expect it to.
That's right. You know, one of the things that we did on our first supersonic flight.
I'm 10 seconds out, subsonic. No need for a shot here. We are done for the day.
Copy that. So fuel state, we had a
We're still in the dark as you're headed back.
Yeah, we had a level, basically we call it bingo, and that's when we have exhausted the fuel for our planned testing for the given day. And so we're at that point right now where we can come back, and there's still some test points we can do on the way home, but we don't have the fuel anymore to do another Schlieren pass.
Great. Well, that makes now 6 times that XB-1 has...
Next up is Card 3 recovery. We still don't have SAS of the aircraft. Anything you're seeing off nominal would be appreciated.
Everything looks nominal.
Okay, so we're nominal. From the control room, that's what Aaron just communicated to Geppetto. It's unfortunate that they're just not seeing the live data that we need to do more testing up at 35,000 feet. But that you heard that call there that everything is nominal. So no issue with the airplane, just unfortunately not getting the data in the control room that we hoped.
Right. So this is really a bittersweet day for me, and I think for the entire XB-1 team, because this is the last time that she'll fly.
I echo that sentiment wholeheartedly, Blake, is that this is so bittersweet. I have been working on this airplane personally for 8.5 years. And what Geppetto's doing now is he's bringing it back. He's going to execute the last before landing checklist, extend the landing gear for the last time, and bring it home for a landing. Very bittersweet because this has been the highlight of my professional career to work on XB-1. But I'm also equally excited about everything that we have in the future for us.
26,330 in the box.
There you go. Can you talk a little bit about what's coming up for us in the future?
Yeah, well, I mean, while it's incredibly sad for me to leave the exciting world of flight testing and experimental aircraft, it means we get to go all in starting tomorrow on what we started the company to do, which is to build that Overture airliner. And so as we speak, we're literally about a week away from calling design freeze on Overture. We'll be calling design freeze on our Symphony engines in March, and our goal is to be making thrust on those engines around the end of this year, start building the first Overture in about 18 months, roll it off the line in about 3 years, put it in the air in less than 4, and our goal is to be ready for passengers by the end of 2029. So while it is exciting to watch flight test, and I know many of you outside the company have been following along as well, cheering us on, and that's been exciting for all of us. We're all going to make the Overture and Symphony development as transparent as we possibly can, show you pictures of things as they're getting built, tell you about what's going on. And I just want to really say thank you to everybody who has made this possible. Most importantly, the team here at Boom, who has committed themselves and pushed through so many difficult problems that others said were impossible or never even tried. The investors that backed us, but also all of our fans out there who have constantly cheered us on and said they're looking for us to win, and that helps us get up every day and keep doing what we came here to do.
Yeah, thanks for saying all that, Blake. And really, we have achieved here with this flight test program what everyone thought previously was impossible, and that a startup cannot do a supersonic airplane by themselves without the help of the government, without the help of the larger OEM organizations. And what we have done now 6 times is shown the world that we can design, develop, test safely a supersonic airplane. So 6 passes, we've broken the sound barrier 6 times at this point. We'll see how the quality of the Schlieren images come out. I hope we get something good there. But I did get confirmation from the team on the ground that all 3 of the passes that we've done today also produced no sonic booms.
Wow, that's pretty big news. I'd like to say the boom heard around the world, but it's actually the boom heard not at all.
It's boom heard by nobody, I think, which is, in this case, really good.
Indeed, indeed. Personally, there's part of me that kind of wanted to hear a sonic boom. But actually, speaking of sonic booms, I think it's kind of worth mentioning, they've got this kind of reputation as being these awful boogeymen, and indeed there was a great old episode.
It's been a pleasure to fly with you. I really hope you guys are successful for your future endeavors.
Likewise, man. It's been a pleasure having you on my wing for all these flights.
You see the interchange there between the pilot and the chase. They're just congratulating each other on a flight test campaign well flown.
Indeed. Oh, incredible professional team that does this. But yeah, there's an episode.
Control approach 167.
There was a episode of Mythbusters a few years ago where they tested the myth, can you break a window with a sonic boom? And it turns out you actually can, but you have to fly supersonic at an extremely low altitude, which of course produces a very loud boom. The boom in some ways is like the wake of a boat. So the bigger the boat, the bigger the wake. And also the closer you are to the boat, the stronger the wake is. But flying up at high altitude, we can put XB-1 or Overture in boomless cruise where literally you don't hear it. But up at 30,000 or 60,000 feet where Overture is going to be flying supersonic, it's a completely different phenomenon. And
so that's the difference between what we call boomless and quiet boom, right? Those are two different things.
That's right. I mean, really, so XB-1 will make no sonic boom at all flying subsonic. Supersonic, when it's in the boomless cruise condition at speeds up to about Mach 1.3, it will make no audible sonic boom. And when we accelerate past that, it'll make a sonic boom, but at a pretty high altitude. And now future generation aircraft can do something that we're not doing on XB-1 or on Overture 1, and that's called low boom or quiet boom, where the design of the aircraft gets shaped such that when that sonic boom reaches the ground, it's quiet enough that it really doesn't bother anybody. So that's something we're looking forward to delivering on future aircraft beyond XB-1 and Overture 1.
And there's really no reason why we couldn't design for a quiet boom. It's just there's no agreed upon standard. So what we can do right now that is easy to do without any certification requirements is to cruise around in that no boom regime. How much faster is that than, like, let's say, a typical airliner would fly?
Oh, it's up to 50% faster. And so to put that in concrete terms, it means coast-to-coast flights are 90 minutes faster. That makes a real difference. And those hybrid routes where we're flying partially over water, partially over land, they're going to get even more speed up because those overland components can be flown boomless cruise 50% faster than today's airplanes.
I mean, like I went on my honeymoon with my wife to New Zealand, and those flights are just so painful. I'm the biggest aviation geek you probably ever met. Maybe we could fight for that. I don't know, but who isn't on a commercial flight? And if the stewardesses came out, halfway through the flight and said, who wants the flight to be done, or who wants to continue on for the second half, I think everybody in every airplane would raise their hand and say, I'd rather be on the ground now. And so that's what we're trying to do here.
Yeah, I mean, that's right. I mean, I don't know a single person who doesn't want supersonic flights so long as they're safe, affordable, sustainable, and quiet to the people on the airplane and quiet to the people on the ground. And that's what we've really demonstrated here with XB-1. We've built a supersonic jet with airliner technology. It scales up and it solves the big problems. It solves the big problems that Concorde had. It solves the sonic boom problem in boomless cruise. It solves the efficiency problem. It solves the takeoff and landing noise problem with turbofan engines. And what that means here is,
Sorry, I just get distracted by the landing gear coming down again, because again, I'm a landing gear engineer and I just geek out on it every single time I see it. And so Geppetto just completed the pre-landing checklist.
Test control, you are go damper.
Dampers coming back on.
Ah, yeah. So we snuck in a test point there. Talk about it real briefly. We did some more dampers off investigation. So here, even in the last 5 minutes of XB-1's flight test campaign, we just did more stability augmentation off assessment of how the airplane flies. And that's going to be very valuable data as we scale that up and apply it to the flight laws on Overture.
That's right. I mean, XB-1 has manual flight controls, but it's got digital stability augmentation. We did that to take a step towards learning how to do digital flight controls. And of course, Overture is going to be a fully digital fly-by-wire system.
So XB-1 is about 5 miles out at this point. And he's lining up, and he's going to get cueing again from our landing signal officer who's standing at the edge of the runway. He's going to help guide Geppetto down for landing.
Contact, winds are right down the pipe. Calm, you're slightly above glide path, you're on center line.
So
1.4 final.
Roger, final.
let's watch XB-1's final landing.
You're on center line. You're on center line. You're on glide path. You're on glide path. You're on glide path. You're on glide path.
And of course, as you can see in the landing here, XB-1 comes in at a
You're on glide path. 50 feet.
Pretty high angle of attack, right?
pretty high angle of attack, right? Yeah, and that's why we need that augmented reality computer vision system.
5.
There we go, another beautiful
Oh, we
touchdown.
greased it. Geppetto has made this look easy every single time he's done it. What a pilot.
Welcome aboard, Geppetto. It's been a pleasure working with you and the team.
Oh, and there goes Wiper. He's having a little bit of fun.
Awesome. So you heard the closing sentiment there from our landing signal officer, and it's been a pleasure. We've talked about this in the past, but in addition to the design, the development, the manufacturing, the testing, also the technique. So we've got this forward-looking vision system for the cueing that Geppetto needs to land the airplane. And that's, of course, so we don't have to have that big, heavy dropping nose like Concorde famously did, just to provide visibility. But we need this experimental system, and we need a safe way to test it for the first time. So we've demonstrated this technique that I'm unaware of anyone ever doing in manned flight test, other than the Navy. They do it routinely landing on aircraft carriers. But we applied that to prove the system out. And I would expect Overture to do something very similar during the initial portion of its campaign, and then once that system's been proven, we'll just land it on the cameras every time. So XB-1's going to slowly roll to the end of the runway. It'll turn left, and then it'll taxi back and shut down right behind us here at the desk. And this really, that will conclude XB-1's flight test program. But we have collected so much data about how a supersonic airplane of our own design performs in the air. So we're just going to get that data, use it to validate our tools, our design tools, our test prediction modeling, and that's just going to inform everything that we do looking out. So this was a battle very well fought to accomplish 13 safe test flights, 2 of them being supersonic, 6 times breaking the sound barrier. This is data that no other team on the planet has, because no other fully civilian, fully independently resourced team has.
Yeah, it's just absolutely phenomenal. And, there are things you can learn about supersonic aircraft design by you're studying history or reading textbooks, but there are things you can't learn except by doing it. And, XB-1, we originally designed very ambitiously to fly faster than Concorde. And as we went through the development program, we started to learn, not just what we could have in a textbook about where the breakpoints and challenges are, but what you learn, integrating, for example, a landing gear into a very long, skinny airplane, what you learn about how the engine intakes work, many other things. And that's allowed us to just become that much more pragmatic about Overture. So cruising at Mach 1.7 as a top speed on Overture 1 is dramatically easier, allows us to use off-the-shelf materials, allows us to meet the same most stringent takeoff and landing noise rules that apply to other subsonic aircraft, and allows us to make the engines easier to build with using only kind of proven technologies. So the lessons of XB-1, not just the things you think about, many things that are more subtle that allow us to make better choices, even on what Overture is going to be.
It's a real 0 to 1 moment having completed the flight test program, right? I have been inspired in my career. I used to go to museums as a kid, just look at the airplanes, hoping that I could do something that cool someday. I'm truly proud to be alongside this team that has now done it. I also hope XB-1 goes into a museum someday, and other kids will look at it for years to come, and that'll inspire them to do the hard thing that they think is important.
Maybe you're out there right now, somebody watching this live stream is the future chief engineer for Overture 3, because we are not stopping with Overture 1. One of the things that we've really stopped doing as an industry is building new airplanes quickly. It's now been 20 years since Boeing or Airbus has introduced an all-new airplane, and I think we need to pick up the pace, not just with how fast we fly, but how quickly we iterate. We need new generations of airplanes. We need to develop them faster, more efficiently. We need to be innovating. We need to be bringing new capability, not just because it matters, the capability, but also because it's an inspiration.
That's right. I was blown away by how many school students watched it live in their classrooms on the last flight. I wonder if that happened again today.
I hope it did, and I hope that all of you watching this will just remember that a small team of 50 people who were told they couldn't do it, was told it was impossible, did it. And if we were able to do that, that means other things are possible in the world too. Well, there we are. The engines are going to be shutting down on XB-1 for the final time, and that marks the close of one chapter at Boom and for aviation. But it also marks the opening of a new chapter, the chapter that we all get to be even more excited about, because next time next time there's a supersonic test flight, it's going to be on the airplane that you and I and everybody watching is going to be able to buy a ticket and fly on. And that is going to be incredibly exciting. But also the real moment that I'm looking forward to is the point where nobody wants to be reminded of supersonic flight, just the same way that nobody wants to be reminded of subsonic flight today, when it is just the normal way for all of us to fly.
I can't wait for that time, Blake. And, you know, our broadcast will be concluding here shortly. But Blake, thanks so much for joining me on the live stream this time. It's been awesome.
Likewise, Nick, it's been a pleasure working with you over the last 8+ years, and I'm looking forward to your next chapter, to Boom's next chapter, and to bringing supersonic flight back for just about anybody.
And thanks everyone for watching, joining us here today from Mojave. This will conclude our broadcast, but 2025 is going to be a really exciting year for Boom Supersonic. Keep following the channel.